Imagine floating effortlessly through space, your body no longer bound by Earth's gravity. No heavy footsteps, no aching joints from standing too long, just endless, weightless freedom. But what if humans lived like this not just for months, but for generations? How would our bodies adapt? Would we still look like the humans we know today, or would evolution reshape us into something entirely new? Gravity has shaped every aspect of our existence. Our muscles, bones, and even our hearts have evolved to resist its constant pull. But in zero gravity, the rules change. Without that force, our bodies begin to weaken. Astronauts who spend months in space return with thinner bones, weaker muscles, and even vision problems. Now, picture this happening over centuries. If humans were born, lived, and died in space, evolution would step in, slowly altering our biology to better suit a life without gravity. One of the first things to change would be our skeletons. Bones grow strong under stress. Walking, running, lifting, all these activities signal our bodies to maintain bone density. Without gravity, bones lose mass, becoming fragile. Over generations, natural selection might favor individuals with lighter, more flexible skeletons, or even entirely new support structures. Some scientists speculate that in the far future, humans in space could evolve cartilage-based skeletons, like sharks, which are lighter and more adaptable. Muscles would shrink, too. On Earth, we constantly fight gravity just to stand upright, keeping our muscles engaged. In zero gravity, muscles atrophy from disuse. Future space-dwelling humans might have much leaner, elongated bodies, with weaker limbs since they wouldn't need to push against gravity. Their movements would become more fluid, relying on gentle pushes and pulls rather than walking or running. Even our posture would shift. Without gravity pulling us downward, the spine would decompress, making humans taller but also potentially weaker in the core. Over time, our bodies might develop new ways to stabilize ourselves, perhaps with stronger tendons or modified spinal structures. Some researchers suggest that without gravity, humans could evolve prehensile feet able to grip and manipulate objects like a second pair of hands, helping them navigate and work in a three-dimensional, weightless environment. The heart, a muscle that pumps blood against gravity's pull, would also transform. In space, blood distributes evenly, reducing the heart's workload. Future humans might have smaller, more efficient hearts, or even multiple hearts working in tandem to circulate blood without strain. Their circulatory systems could adapt to prevent fluid buildup in the upper body, a common issue for astronauts that causes puffy face syndrome. But it's not just our bodies that would change, our senses would too. On Earth, we rely heavily on balance, using inner ear fluid to detect up and down. In zero gravity, that system becomes useless. Future humans might lose their inner ear balance organs entirely, relying more on vision and touch to orient themselves. Their brains could rewire to process movement differently, making them far more adept at navigating complex, spinning space stations or floating habitats. Reproduction in space adds another layer of complexity. Scientists still don't fully understand how zero gravity affects pregnancy and fetal development. Would babies develop properly without gravity guiding their growth? Over time, evolution might favor adaptations like stronger umbilical cords, modified womb structures, or even new birthing methods to ensure survival in space. And then there's the question of size. In zero gravity, height isn't a disadvantage. There's no risk of toppling over. Future humans could grow much taller, with elongated limbs for reaching in all directions. Conversely, if resources are scarce, natural selection might favor smaller, more energy-efficient bodies. Perhaps the most fascinating possibility is how our brains would evolve. Living in zero gravity requires entirely new ways of thinking, navigating 3D spaces, solving problems in fluid environments, and adapting to constant change. Future humans might develop enhanced spatial awareness, faster reflexes, and even new cognitive abilities we can't yet imagine. But evolution is slow. These changes would take thousands, maybe millions of years. And by then, humans might not even be purely biological. Genetic engineering and cybernetic enhancements could speed up adaptations, merging biology with technology to create the ultimate space-dwelling species. So, would zero gravity turn us into floating, slender, long-limbed beings with prehensile feet and hyper-efficient hearts? Maybe. Or perhaps we take a different path entirely. One thing is certain: if humans make space their permanent home, evolution will ensure we're no longer the same species that first left Earth.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.